Okay, so the bell rang, so I want to finish this question. The division of two complex numbers really breaks down to just being able to multiply. If we can figure out what to multiply by, so I'm going to multiply by something here, and what we do is we always want to multiply by the conjugate of the denominator. Okay, if you remember what conjugate means, is that the first term and the last term of the binomial are the same. But if this is a plus sign, this becomes a minus, and vice versa. Okay? And what's nice about that is if they are like this, basically what happens is if I do the FOIL technique, so we're going to multiply. First times first is going to be 25, but outside times outside will give me negative 20i, and inside times inside will give me positive 20i. So those two things are additive inverses, and they cancel each other out. And we know that that will always happen. That's a true fact about foiling conjugates. Okay, so it allows you to do maybe a little bit of shortcut work here in a moment. But now I'm going to multiply top by the same thing. All right, so hopefully you realize that all we have done here is multiplied by a factor of 1. Okay, so that's going to effectively do this division for us. And it's going to break down these two complex numbers down into one complex number. Okay, so I'm going to do this multiplication. So on the bottom is easy. The bottom is 5 times 5, which is 25. And like I said, I'll do it just for the sake of the problem, but if I do outside times outside, so it gives me negative 20i, and then inside times inside gives me positive 20i, and then last times last gives me negative 16i squared. Okay, but again, hopefully we're realizing those two things cancel each other out. Okay, so the denominator is really going to be 25 minus 16i squared, but that I squared is actually a negative 1, so negative 16 times negative 1 becomes positive 16, and my denominator is really just 41 when I add 25 and 16. So that's really nice, because now you see that we've gotten rid of that complex number 5 plus 4i. Okay? Now we need to do a similar thing up top, but now because they're different complex numbers and they're not conjugates anymore, we're going to get a little bit more complex looking numerator. So I got 2 times 5 is 10. 2 times negative 4 is negative 8i. 3i times 5 is positive 15i. And then 3i times negative 4i is negative 12i squared. So again, that negative 1 shows up as an I squared, so I squared is negative 1. We'll change this sign then to a positive. Okay, and that will go away. So now I'll end up with 10 plus 12, so that's 22. And then negative I plus 5, or 15i, is 7i. And now what we end up with is this complex number, which can be rewritten maybe a little bit better as, and it doesn't matter, you can type it in this way, I don't care. You write it that way, or you can write it this way and type it in this way. And most people are going to maybe feel more comfortable with that, because then we can identify that that fraction is the real part, and this I here, if you want to put it out like that, that's fine, and that then is the imaginary part. And that's simply how we divide complex numbers. You see how you started with 2 complex numbers, okay, and the quotient of them then ends up being 1 complex number. All right, we have to go through this process of multiplying by conjugates to do that. Okay, the number one thing people mess up on is that they want to multiply by the conjugate at the bottom here, and you get a 5 minus 4i, but then they want to do 2 minus 3i up here. Remember, you have to multiply by 1, because we can't change this quantity. We're just basically changing the way it looks. Something you might see in your homework, I don't know, I tried to avoid questions like this that involve this, but it might pop up. The first thing is that a lot of times we refer to complex numbers as a z. Okay, so we say like z is a plus bi. Okay, it's just the notation that we use. So maybe, z is equal to 2 plus 5i or something like that, or z is equal to 3 minus 2i. If z isn't around or able to be used, maybe sometimes we use w, and w is then equal to 4 plus 4i or something like that, or w is equal to 13 minus 3i. Okay, it doesn't really matter, but a lot of times we like to use a complex number and set it equal to z or w, and you can use any letter you want, but those are the two that show up the most. And this will make a lot more sense later on when we start graphing these things. We deal with the complex plane and Argand diagrams and stuff like that, which we'll get to when we get to trigonometry. But WebAssign will also do something like this. They'll say if z is 2 plus 5i, then they'll say z bar. Okay, z bar is just a way of saying conjugate of z. Okay, so if z is 2 plus 5i, when they say z bar, they mean that is equal to 2 minus 5i. If they come down here and say w is 4 plus 4i, then w bar would be the conjugate of w, so 4 minus 4i. Okay, so that's one notation. You might see another notation that's kind of messy sometimes. You don't see this one very often, but WebAssign did have a question. I avoided it. I didn't assign it to you, but it does use this. It might write like 2 plus 5i and put a bar above that. And really what that means is conjugate of 2 plus 5i. So it's 2 minus 5i is what they're talking about here. I don't like this. You don't see this very often. There's a college course. It's a graduate level course actually called Complex Analysis. Okay, so that's an L. Complex analysis, where you investigate the complex plane. You start learning the ins and outs of it, the algebra of it. Do a lot of proofs inside there. But in that course, you'll see the z bar notation. Sometimes I think you can see like a z and they put a star above it. That might be a notation. But you very rarely, if at all, will use that. That's kind of, I've never seen that other than inside WebAssign. But that's just a little bit of information there that might be useful for you. We'll talk about this in class again tomorrow briefly, but I wanted to have something there for you to look at in the future when you finish that homework.